All right, it's rolling. So we're going to do this. So we got a car. It's going down the track. And it's going 8 meters per second, and it's got a 14-meter head start. Okay? Now, later, after this thing's 14 meters down the track, another car takes off. Another car takes off at 12 meters per second. How long is it going to take that car? We were just going to, this is a double line graph. That's how we're going to solve it. We're going to say the formula for going down the track is xf equals vt plus xi. So the velocity of the first car is 8 meters per second for some certain amount of time, and it's got a 14-meter head start. Now the other car, I'll do this one in red. Its formula is xf equals vt plus xi. This one, however, does not have a head start, and its velocity is 12 meters per second. All right? So it's also equal to xf. Now when the cars collide, that means that both of these xf's are equal to each other. So we can just set up a formula. 12t is equal to 8t plus 14. This is really 12 meters per second for a certain amount of time. If I'm trying to make it look 12 meters per second, t. All right, so we're just going to solve for t. I'm going to switch to blue here. I have 8t right here. That's going to leave me 12 minus 8 on this side with 4t. Everybody agree with that? 4t equals 14 meters. So let's solve for t. 14 divided by 4 is 3.5 seconds. Right? So that's how long. That's how long. It's 3.5 seconds. How far down the track will this occur? Well, in these problems, you can insert the 3.5 seconds into either side of the equation and you'll get the right answer. The simplest thing to say is if this guy travels at 12 meters per second for 3.5 seconds, then you just have 12 times 3.5, which is, what's that, 42?
Yep.
42 meters down the track. Does that make sense? So, there we go. We'll do another one in a second. All right, so this problem right here is very different because the head start in this problem is, this car has a head start of 15 seconds. So the slow car has 15 seconds, all right? And it's only going at 7. Then a faster car begins to chase. So think about how the question is asked. How far down the track and how long will it take the faster car to catch the slower car? All right. First of all, if we're thinking about, the question says, how long will it take the faster car? So if we think about the slow car compared to the fast cars, the slower car, its time plus 15 more seconds. That's the time for the slow car. 15 seconds more than the fast car. So if we were going to write xf equals xi plus vt for the slow car's speed, it's got a head start of 15 seconds and its speed is 7. So you could say 7 meters per second times t plus 15 seconds. Everybody like that? So that is the final distance for the slower car. All right, if we're writing a formula for the faster car, it has no head start and its time is t equals 0 when it starts. So its final distance is x is just going to be vt. There's no xi because it doesn't have a head start. So it's going to be traveling at 13 meters per second for only t seconds. So these xf's will be equal when the cars crash So the simplest way to write this is to say the 13 meters per second for t seconds is equal to 7 meters per second times t plus 15 seconds. First thing we have to do here is distribute this 7, right? So I'm going to change my color here. So we've got on this side 7t plus, what is that?
105?
105?
That's what the calculator is.
Yeah. 7t plus 105. On this side, we've just got 13t. And now we're going to solve. 13t minus 7t. 6t is equal to 105. Everybody like that? And then t is equal to 105 divided by 6, which is, was it 17 or something? What is it?
17.5.
17.5. So the time is equal to 17.5 seconds. That's how long it's going to take the faster car to catch the slower car. Now, there's a catch to this problem, because it says how far down the track. Now, if we're thinking about this graph, right? If we're thinking about it the way we've written it, we're saying to ourselves, hey, the slow car, it started going 1, 2, 3, 4, 5 seconds before the fast car, right? And we're saying the fast car, Islam's a little bit steeper, so it's going to catch it. Does that make sense to everyone?
Yes.
So the head starts in time, but the question was how far down the track. Now that's the catch. The catch in this problem is it says how far down the track. So we can't be calculating the blue car because in reality, watch this, in reality, the start line, some of you are not going to like this, in reality the start line is actually all the way back here, isn't it? So think about this. If we just say, okay, the faster car went 13 meters per second for 17.5 seconds, that's not the total distance, is it? That's the total distance that this guy drove. But in reality, the slower car started at the same. So when we calculate the 13.5 seconds that it takes, we have to put it into the slower car's formula. Does that make sense? Do we? Well, let me ask you a question. What does it mean to catch the next car? It means you're both at the same place down the track, right? So they're both actually driven the same distance. But you're only going to get this answer, this much distance, if you put the 13.5 in the wrong place. Does that make sense to you? Let's take a look at it. Am I saying the wrong time? 17.5. I'm sorry, 17.5. So we're going to take the 17.5 seconds, and we're going to put it in to the slower car's formula, aren't we? Is that what we're going to do? Tell me, what do you think? All right. Let's try it, because we get two different answers with it. All right. Let's see if we get two different answers. 13t is 13 times 17.5. What answer we would get there? Y'all calculate that real quick. You get what? 123.5 meters. I like that. Now let's put 17.5 into this equation. Oh, what? 13 times Somebody yell out, what is 13 times 17.5? Yeah, it's got to be 13. What was it?
227.5.
Yeah, sorry. Sorry, people at home. Somebody yelled out the wrong answer. All right, there we go. Now let's try this. Let's try putting Gesundheit. Let's try to put 17.5 into this, right? 17.5t. Let's try that one. Let's try to distribute it over there. Hang on, James. Just want to try this. Yeah, what was that, buddy? Let's try for this car, XF, good, that's what we want. XF is equal to XI plus its velocity is what? 7 meters per second. 7 meters per second. Yeah, I'm trying, the board's messing up, that's not me. 7 meters, why are you not writing now? 7 meters per second times t plus 15, right? And the t here is what? 17.5 plus 15. What are these two? 32.5. And what's 7 times 32.5? Same answer?
Yes.
Perfect. Perfect. Is this the same answer?
Yes.
All right, good. So if we do it right, we can put it in either side. We can do it either way. We did one on Friday. Remember, we did one on Friday, and we worked the question as if it was asked about the wrong car. So the only way, that's right. Here's the way we could mess this up. Is if we did this problem, everybody at home especially too, the way we can screw this problem up is we have to remember that the problem is about the fast car. So we have to put t plus 15 here. If you put t minus 15 for the fast car, that's not the same thing. That's two different answers. Does that make sense?
Mm-hmm.
You can only do t plus 15 for the slower car. All right, everybody with me?
Yep.
All right, what do you think about it?